The Mississippi Delta covers about 10,000 kilometers square. It is very important for biodiversity. It is also very important to protect the coast against sea level rise and also against storm surges during hurricanes. We have noticed that since the 1930s, 25% of these marshes have been lost. We were able to estimate the rate of loss to be equivalent to about 1 football field per hour. The only way to stop losing that land is to first understand how we can build land rather than lose it. And this way we can maybe do better engineering of the coast and try to keep all the sediments within the marshes rather than flushing it through the ocean.
We're trying to understand how much water, how much sediment, and how much carbon is moving from inside the continent of North America out into the coastal ocean, and then what happens to all of that stuff once it gets into the ocean.
We have 3 aircrafts with 3 different instruments on board, flying simultaneously, in addition to 2 boats underwater, everybody at the same time. And we're going to do that at high tide as well as low tide. We're validating our remote sensing measurements with these boat measurements from the field. The UAVSAR we are using to look at the progression of the tide within the salt marshes. With the system ASO, which is a LiDAR, we are trying to retrieve slope of the rivers. So if we're able to estimate the slope of the rivers, we can also estimate the amount of water that is being discharged by those rivers. We have a third instrument, which is Abris NG. That one is an imaging spectrometer. It's basically looking at the water color. It will be used to estimate the amount of carbon and sediments within the water.
The spectrometer measures how much sunlight is being reflected off of the water. But it's not just the total amount of sunlight, it breaks it down into different colors of light. And so we can use that information to help us understand how much sediment is in the water, what kind of sediment, how much carbon is in the water.
We installed water level gauges all along the river. They are basically little sensors that measure pressure. With these gauges, we'll be able to determine the slope of the river at any given time. We're recording the levels every 5 minutes. So when we go with the airplane, we can compare our airplane measurements, the remote sensing measurements, with what these water level gauges are measuring. So we're trying to capture if this river impacts the water level here.
Okay. That one?
Yeah, this one.
That one. Okay.
We're trying to develop techniques that relate the water spectrum to the water quality. So we have to relate the observation to what's actually in the water. For that, we need water samples. And with these water samples, we can quantify the amount of carbon and sediments that are in it, that we can then compare with the remote sensing imagery.
Okay, light started.
There's nothing like remote sensing because you can see instantaneously the entire landscape in one shot. And we can do it multiple times and monitor the hydrology of the system as a whole. So this will be very important for us to model these systems and try to forecast what will happen in the future systems. Will they survive sea level rise? Will they survive the next storm surge?